For this week, we learn Spark. What is Spark? We have learned about MapReduce in the last week. If you think about MapReduce, it's a low-level language, and Spark is high level. It will do the same things that MapReduce will do, but in a more efficient way. So right now, most people will write the big data processing software using Spark instead of MapReduce. We will see why that happens, but let's briefly discuss Spark first. Spark was originally written using Scala language, and after that, Java API and Python API was added. If you want to learn more about Scala, I recommend you to go to http www.scalalanguage.org. There are all the details. But let me give you a very simple tour of Scala language. You declare variables in the same way that you do in Java, and you define functions in this way that's similar in the Java language. Okay, so it's just a different language, programming language. It should be obvious for you to learn. But we will focus on Spark language. In the Spark, normally we do there are three things. Normally we declare RDD, resilient distributed data set, and that's essentially just variables. RDD is some kind of variables. For example, we use variable lines to get a Scala, SC means Scala Spark context, text file from HDFS. From HDFS, we load this file into this line. So it's this variable lines contains the entire data set from here. So that's the first RDD we have. After this first RDD was defined, we can define other RDDs. They are called transformed RDDs from this original RDD. For example, the arrows. The arrows will be all the lines that start with the arrow. So that means we just filter out the lines that does not start with arrow. So arrow contains all the lines from this file that contains the arrow for the first beginning with arrow. And the message is again defined by split using the space from arrows. So that basically means we have original base RDD here, and from this RDD we define two other RDDs. So that's called RDD transformed RDD. And then the more important thing called action. Action is essentially we try to get the reduce. We try to count, for example, the message field contains MySQL. Okay, so we try to find out how many errors from MySQL comes from this file. And this another one message field contains PHP. How many lines in this file is for PHP? So that means, so this is essentially easy for you to understand. For all the Spark language, we have three things to do: declare get the base RDD, declare the transformed RDD, and then do some kind of actions. In the practice, it looks like this. First, we try to put a drive there and we submit work in the HDFS, distributed file systems. And then we just ask this something to do this, like actions. First, we do action, but this action won't. And then we do, in order to do this, the driver will send all the works to from this base RDD, you get this transformed RDD. And it will do some kind of read HDFS from this file into these different works, like map part. And then it will just process the data in the cache to find out what kind, how many MySQL comes from this, how many lines in this file is for MySQL errors. And then the results will be returned to your driver, what you have done. And then the first thing, now the first action is done, right? So after here, we get the result for first action. Now we try to do the second action. We try to count how many lines in the error message is from PHP. Now we do the same things. We will process things, but this time it will be different, because in previous time we have to load the HDFS file into the workspace and then get the error RDD and then get the message RDD. But for this time, because we have cached the message already, we do not need to go back to read all these previous RDD and process to get this the error RDD as a message RDD. So we can directly return the result, just count how many PHP has. Now you see the efficiency, why the efficiency come from here. The efficiency comes here because if you look back to the MapReduce, for every time, if you do the MapReduce for action 1, you have to do 1 time for the entire process. For action 2, you have to restart the entire MapReduce again and do the same thing. But for Spark, we do not need to do that. We have 1 action, but then we catch the intermediate result, and when they use this intermediate result for the action 2. In the high level, it looks like this. So we from one original RDD, resilient distributed data set, we get many transformed RDD. Transformed RDD only exists in the concept. It does not actually exist yet. You just define the transformed RDD is obtained from the base RDD. So we have many concept RDD. The RDD, this transformed RDD will exist only after actions. Every time if you take 1 action, you will this RDD will be actually be constructed. And when the RDD are constructed in practice, then it will be cached and it will not be constructed in next time. Okay, so that's a high-level discussion about the so first RDD is a line. So we read this first RDD, right, from the HDFS files, and then we use transformations. These lines, errors and messages are constructed from this original RDD, but they are not actual object. They are only constructed from this concept. They do not exist. Only after you do some action, this RDD will be physically constructed, and then you will get the result. And then you can do the next action and using this constructed RDD. So that's a very high-level discussion about the Spark language. And we have all the details in my PowerPoint slides, and you are recommended to finish all the slides for Spark language.